Definitely a pleasure to be part of this group and sharing some of my experiences along my Kubernetes journey and some more recent discoveries that I've made in the open source world. So one of the things that a lot of us keep hearing all the time have to do with fancy trends and fads and other things. So um, we're used to working in a particular way, and along comes a technology that totally changes the way we've done things, and then we all scramble and try to retrofit this stuff into our workflows, or we end up discovering new workflows, newer ways to work, better ways to work. And this whole phenomena is just, I guess, repeating with Kubernetes right now. That said, all the things that we're hearing about Kubernetes and speaking to all of the people who are working with it, there's definitely so much positivity in terms of what Kubernetes is capable of, what it can provide, and how it can really transform the application rollout and maintenance and stuff. However, it comes with a small caveat. Um, just like we saw in the previous presentation, it can definitely be a very complex sort of beast. There's really very many moving parts. There's a lot that's going on in terms of the number of subcomponents, so to say, and it becomes very difficult given the limited amount of time and bandwidth that a lot of small teams and agencies and startups and indie developers have. It definitely puts it out of reach for a lot of these people, and that really reminds me of a story that we've heard as kids, where there's a fox can't reach the grapes, and then it just walks away saying, "Oh, the grapes are very sour." So a lot of people who I have interacted with, and this is not just in some parts of the world. This is across the world. All of them would like to have Kubernetes, but they just don't have the time and the bandwidth and the energy to pursue it. So a lot of people just leave it. So my talk today is about how the open source community around Cloud Foundry has been able to create a PaaS experience for layering over Kubernetes based infrastructure, and that'll solve a lot of the problems. And it's not just about solving some of the problems that exist with Kubernetes, but it will also provide a wonderful experience idiomatically. Like the basic and the fundamental experience for developers is simplified, is better, and is just so much it makes Kubernetes so much more usable, so to say. So I've divided this talk into three sort of very rough pieces. I'd like to talk about the past for a little bit and see how we were led here. And then I will provide some details about what is the current state of affairs and the state of the union, so to say. And then we will look into the future, and we will see what lessons have we learned from the past, and where is it that we can springboard from where we are at today. So here's a small history lesson for those who are interested, and it basically starts off with this pursuit of developers wanting to deploy applications, but not wanting to take on a lot of the complexity that comes along with it. So there's always been a pursuit of, is there a simpler way to deploy applications? Is there an easier way to sort of maintain these? Is there some way in which we can avoid a lot of um, um, the toil that comes along with deploying and maintaining applications and so on? And then obviously what people were after was the ability to deploy more frequently, deploy at will, and basically go from like a waterfall model of long past to agile models of slightly more recent past to try and deploy as many times as you want, not wait for cycles, respond to the market as soon as changes are required and things like that. So the ease of deployment was basically so that the velocity with which software got deployed could be more and could be made faster. Now, in this context, especially about when talking about the history of PaaS, it's very pertinent to mention Heroku. So, Heroku was among the first players who changed this whole game from if you have a code base and you wanted to deploy that code base, all you had to do was git push Heroku, and it would handle a lot of things beneath it. And so, because of the efforts of the Heroku team, we we were able to create some mainstream impression of what a PaaS should look like, how a PaaS should operate, and what a PaaS should be able to do, and stuff like that. So, in my experience, at least, Heroku was among the first tools to really sort of be that game changer and be worth its weight in gold. That said, Heroku was also very expensive, and it was definitely a lot of gold for in exchange for what Heroku could do for a developer. But all of these things that we've been speaking about in terms of obfuscating a lot of the complexity, abstracting away all of the unnecessary internals, and stuff like that, the Heroku team did like a wonderful job of that. And so I think no discussion about PaaS and no presentation about PaaS is complete without taking a look at this version of uh, the stack. So um, this was formalized again about 8 or 10 years ago when PaaS started to become mainstream and was starting to provide a lot of value in terms of what it can and cannot do. And this is basically a sort of very interesting overlay of here's the different constituents of every single technology stack, and here's what you get in return for using a PaaS. So it helps contrast with other options that people have, and as long as developers and engineers were capable of and handling um, changes to the application in the form of code and to the data in terms of databases or underlying file systems and other architecture, things would just run smoothly. And um, the reason I wanted to put this was so to just allude to some more architecture blocks that will come later, and which brings us sort of to the present. So what do we have right now? So right now we have systems where source code or application code is treated as the base unit. So version control is basically used to create code base that remains as the single source of truth for any application. Code has also been able to incorporate everything from infrastructure above, and so we have new and very um, sophisticated paradigms such as infrastructure as code. We're able to containerize all of the applications that we have. Containers are again the unit of deployment for a lot of people, and so um, today right now, with Docker and with all of these things, it's just become so simple, so easy, and so straightforward for people to just pick up containers, write up a few Docker files and things like that, and start deploying applications. And so the barriers to thinking about here's an application, here's how it runs, here's where it runs, all of these different applications, even if broken down into like microservices and use different like polyglot means to be written in, all of these can be condensed into these two paradigms. So at the end of the day, you have code, and that code has to run inside containers. So the world has become very used to this paradigm today, and the world is very comfortable in operating within this framework. And so that has given rise to this DevOps movement, so to say, and that's really caught up in the past 10 years, where um, development and operations are not necessarily viewed as two independent responsibilities. They can be done together, but that's sort of again a very narrow view of what DevOps is and what DevOps can do. So it's also more about here's a set of problems that belong to the dev domain, here's a set of problems that traditionally belong to the ops domain, and today you can count on sort of having responsibilities that span both of these areas. So there's an analogy of the blind and the lame, where a blind person can basically walk and a lame person can see, and so they just sit on top of each other and go wherever they want to, and they can get there fine. So um, it's a similar sort of situation where there's no wall across which you just toss your code and say it's an operator's problem from now on, and then operators throw tickets back across the wall and say, hey, your code is broken. So it's more of bringing in transparency to the workplace in terms of this is how code is functioning on in production, and uh, the responsibility of having that code run properly and without problems is basically a shared responsibility between those who are developers who've written the code and operators who might be operating the platform, or it might be the same person, or it might be two teams, what have you. So the again, it goes back to uh, code and version control being at the center of, or being the starting point for all of this activity, and containers being the platform operators is paradigm of choice, right? And what this has given rise to more recently is this term called cloud native, and it has been doing its round for a while, but right now cloud native is definitely on the forefront of everybody's digital transformation effort. So um, everybody wants um, to be part of this quote unquote bandwagon, I guess, but everybody wants to work with cloud native technology. Everybody, they definitely, the world definitely sees the merit and is attracted to cloud native as a way of not just deploying to the cloud, but having you know um, the even from the first stages through the pipeline and up to deployment, and have all the operations all operate in a cloud first, cloud native paradigm. So that's really the definition, and that's what people are going for. So in terms of tools, what does this look like? So obviously, so just recall this slide for a minute, and I'm just trying to build a parallel there, right? So obviously, for code and version control to be at the helm of everything, the world's favorite example right now is GitHub, I guess. But obviously, there's GitLab, which is by no means inferior or anything. There's and GitHub is just an example. Um, there's also like Bitbucket and all of these wonderful version control tools. It's just that I'm giving an example of one of the more popular ones. And then for containers and containerization, obviously Docker is the one um, that really brought things to the forefront, and made containers so easy and so accessible and stuff. Obviously, containers were around a lot earlier than Docker came along and made it glamorous, so to say. Of course, we're past the history section of the talk, so I won't get into Linux containers and how they achieve namespaces and separation and things like that. But basically, Docker came along and really changed the way people had access to containers and made it more accessible. Now, the third thing we had was um, DevOps. And so, what does tooling look like for the DevOps space? That's what it looks like. All right. So this is an image that I borrowed from the folks at at the Cloud Native Foundation, the Cloud Native Computing Foundation. I'm sorry. So CNCF plays a major role in making tooling available for the people who are looking to move to or looking to operate in a cloud native way. So they have like a very robust incubation program and a graduating program, and all of these tools, I guess, are open source, or rather, a significant portion of the companies that are contributing to these also have like an open source um, code base, and there's probably other parts of each of these companies' code base that's not open source, but then whatever is accepted into like CNCF and graduates from there is definitely open source. So um, everything you want is available. So if you wanted some form of infrastructure, if you wanted some form of uh, tools to host them, to provision them, to manage them, automation, registries for your containers, security tools, orchestration tools, storage, networking, services and service brokers, all of the different databases and data and number crunching tools that you want, several options for continuous integration and continuous delivery, not to mention all of the observability that you need, and the metrics and the logging and any tracing infrastructure that you need for production are all available through some of the tools that are members of the CNCF. So that's what tooling looks like. And um, just in terms of sort of some non-technical statistics for about this and for the cloud native ecosystem, is there's over 1,500 um, companies and tools that are basically working with the Cloud Native Computing Foundation. Between all of them, they have nearly 2.5 million GitHub stars, which I guess makes sense to a lot of people. They're operating software that's worth well over $20 trillion in terms of market cap, and just between them, they've all managed to raise around $65 billion in venture funding. So for any um, entrepreneurial minded audience who are out there, just something that you can chew on. But all of that being said, right, so um, our evolution into the space of having code as a fundamental unit of development, having containers as a fundamental unit of deployment, um, and all of these different tools that can work with these uh, two sort of cornerstones, and work with everything in between. One thing that a lot of people have started to ignore, and not just ignore, but it's fallen through the cracks, is the whole developer experience, right? So what is it that a developer expects when working with code, and what is it that a platform operator actually needs to make sure that the software actually works, the application stays hosted, the application is functional. So obviously it goes without saying that developers want to code. They want to pick up requirements and user stories or whatever it is that they use as they come in. They want to write code that solves the specific business problem, and they want to be focused on the domain of having code carry out all of the different requirements. Operators want a simple way in which this code gets taken and gets deployed to their infrastructure. If that infrastructure can be Kubernetes, then it's all the more uh, desirable, right? So uh, basically what they want is pick up the code that's being written. Once I'm done, once I've checked it in, once it's passed all its tests, just deploy it. So um, engineers want to write code, they want to receive feedback on in any form on the code that they've written, and they just want their code to run and work on like the infrastructure. And operators want to enable this mechanism where once you're done with code and once you check it in, then it comes back and we're able to provide you, sufficient information in terms of feedback, so you can improve and make things better and process things much better with the code that you're writing. And so this is our definition and vision of the future. So engineers and developers write code, and it runs on Kubernetes without, without too much complications and without exposing engineers to all of the complexities that can come with running and operating on Kubernetes. And so, in a throwback to something that a wise man once said, um, the the sort of um, deep design vision for uh, what we would like is, here's my source code. So an engineer says, or a developer says, here's my source code, run it on the cloud for me, I do not care how. So this was a famous haiku that is attributed to Onsi, um, who was like, um, one of the chief technologists at Pivotal, which is where um, Cloud Foundry first took shape. So today, we are positioned at the Cloud Foundry Foundation. We are positioning the Cloud Foundry experience on Kubernetes. So, what that means is Cloud Foundry over the past many years has become one of the best standards for developer experience on virtual machines and VMs. And so, uh, Bosch, which has been the mainstay of the Cloud Foundry technology, is extremely popular and helps host like trillions of dollars worth of software right now. So there's banks, there's governments, there's major financial institutions who are all working with Cloud Foundry, and there's also like tons and tons of other sort of uh, medium-sized firms, a lot of smaller agencies who operate within the Cloud Foundry ecosystem. So the success of the Cloud Foundry experience is now being ported to Kubernetes based infrastructure. So if you go back to sort of this picture, um, why I say that this is what we are inventing as the future is, um, the Cloud Foundry experience basically means, you take your code, check it out of version control, or once you finish development, you just do CF push, and that triggers the first step of your CI/CD pipeline. Now you might have like 5 stages before you qualify it for production, or you might have like one stage, or you might be directly sending stuff to production. So it really doesn't matter. So that's the kind of abstraction, and that's the kind of successful PaaS experience that Cloud Foundry has brought to developers. And now we are at a point where we can make this promise of a wonderful Cloud Foundry ish, Cloud Foundry ish, not ish, Cloud Foundry developer experience for your Kubernetes based infrastructure. So your basically the developer doesn't need to know what Istio is, they don't need to know what service meshes are, they don't need to wrangle with like service brokers, they don't need to know if pods are running, they don't need to manage errors, none of that stuff. So they focus on applications, on code, and they just continue to deploy, and all of this other um, management of operations is done separately on a separate thread. Now, whether a developer does it or you have dedicated operations folks, that's a completely different issue. And let's take a small dive into this project and see what it is. So the project is named CF for Kids, which is obviously like, I guess, very straightforward. So the Cloud Foundry experience for Kubernetes based infrastructure. Um, Member organizations of the foundation who are very active contributors to this are folks from VMware, folks from IBM, folks from SUSE, and folks from SAP. So these are among the four that I can remember, and there's obviously, because it's open source, there's like hundreds of other contributors as well. Um, and and one of the goals for CF for Kids is to adhere to uh, principles of the open source community, obviously, and also maintain open standards. Now, historically, Cloud Foundry, they were, um, when it was, let's say, pivotal Cloud Foundry, for lack of a better term, when they were completely owned and operated by Pivotal, they had a lot of proprietary and custom standards for um, what components worked inside. So they had a parallel to Docker. They had a parallel to Kubernetes. They had a parallel to a lot of different technologies that were already available and a lot of people were using. And so, one of the more conscious decisions that the community and the foundation has taken in the past few months, maybe years, is let's reinvent the Cloud Foundry experience for Kubernetes based on a lot of open standards and based on a lot of components that are already open source and available and within the Kubernetes ecosystem, right? So that's one of the things that that we are aiming for. Another thing is, all of your applications should run using Cloud Foundry. So there shouldn't be exceptions when we're talking Cloud Foundry deployments. It's not like, oh, we'll work for like a bunch of the Java and the Ruby and the uh, um, PHP apps, and then if you're using something very um, you know something like, let's say, Flask, and then we won't work for that. So irrespective of what languages your apps are written in and what your apps do, and whether they're like small apps, big apps, whether they're just services at the back, it doesn't matter. It should all function by being deployed through Cloud Foundry and onto Kubernetes based infrastructure. And not just that, it should work irrespective of which infrastructure provider and which sort of Kubernetes provider you're using. And over and above that, even if you have like a multi cloud deployment, like let's say, for example, you have a system where um, all your code is on GitLab, and then your local testing infrastructure is running on DigitalOcean Kubernetes, and your production infrastructure is running on Azure Kubernetes. Cloud Foundry should be able to trigger this entire pipeline just by doing CF push on the developer's code base. So there should be no problem in sort of defining the pipeline irrespective of any of this multi-cloud deployment that you do, or even if you're on just single cloud, just different clusters and things like that. All of these combinations must and should be and will be supported by um, CF for kids. So that's another uh, big aim that the team has. And so now I'll break down what or how the life cycle of this entire thing happens. Um, the CF push basically creates like three distinct sub processes. And so the life cycle of an application after you push your code to Cloud Foundry is that you first receive like a bunch of build triggers, right? What we like to call build triggers. Um, and I'll break this down. Sorry about that, snafu. And then build packs, which is a major lesson that came out of Heroku and which was developed further by independently by both Heroku and um, the Cloud Foundry team at Pivotal. That sort of has an important role to play in how your code is basically taken and converted into OCI compliant containers. And then finally, there is the release process where your containers are taken, deployed onto Kubernetes nodes, and the entire set of role-based access control, monitoring, and logging, and all of these get attached. Now, why all of this is important is because this stuff is required because you need uniformity in the experience for all developers. So you don't want like different commands for different languages and things like that, right? So it's not like, so in the olden days, right, Java code bases meant you need to package into like jars or vars, or and then you have to deploy into your application runtime. So and then there's different things that you did for different servers basically. So PHP code was just update the code on the server side and do like restarts, and then those became rolling restarts and stuff like that. So um, all of that, all of those differences in terms of build triggers are eliminated with CF push. So that is one of the aims that we had for behind, and that's one of the reasons for this design decision basically. And then there is build packs. So build packs are important because now your servers are basically getting hit with code that is in different languages, right? So build packs are required to basically figure out whatever language and runtime and framework this is, and convert that into appropriate like build artifacts and create OCI compliant containers out of it. Now, um, CF Arcades actually uses the cloud native build pack specification, and they make use of Paketo, which is like an implementation from VMware, specifically for building the containers and things. So there's Paketo build packs for like different languages, for like Java, Node.js, Go, PHP, Ruby, what have you, right? And then finally there is the release stage where, again, what a lot of developers expect today is they don't want to be writing their own logging infrastructure, and they don't want to be writing their own monitoring stuff. They don't want to be writing different parts for security and things. They just want one uniform thing, and they just want it to work. So the release phase is basically attaching all of these different um, parts to the containers that are ready to be, and deploying those containers onto like the Kubernetes infrastructure. And so if I have to break that diagram down into like further pieces, um, so CF push basically uploads all of the code to to what is known as the cloud controller in Cloud Foundry parlance, and then it basically triggers a build, which is it identifies, it basically tells it tells the server, okay, here's the stuff that needs to be built. Go figure out what build pack this requires, and go for it. So, and then it steps into the build packs phase, where the build packs detect what language this is, and so it's basically a very simple detection phase, right? So if you have like a package.json, it will assume that this is okay, a Node.js code base. If you have some composer and other things, then it'll obviously say, okay, this is some PHP stuff. And if you have like Java related artifacts, then it will obviously detect it as a Java code base, and it will use the appropriate build pack to actually start defining the container. And so at the end of this process, now there's like a handful of things that happen here, but basically what you need to know is the right build pack gets detected, and an OCI container gets exported for the code that you have. And after this is all enablement of this container on Kubernetes. So the container gets deployed, containers are hooked with all of the different things, and then the routes are created, ingress and all of that gets created, load balancers and other things get configured as they're supposed to. So in terms of Kubernetes services, this is Istio, the OCI containers that are generated are loaded onto like a blob store, and then basically an engineer or a developer gets feedback whether an app has been deployed successfully or not. So this is sort of an X-ray view of what every individual cluster looks like. So all of these different pieces we've spoken about in different depth running up to now. But basically, um, the blocks that you see here are very specific to Cloud Foundry. Some of this is borrowed from the stuff that we were doing before and just been transformed for working with OCI containers. And a lot of these things are, open source components that are available today. And so build packs can be replaced by Paketo. Blob store is basically Minio. And then for a database, we use Postgres internally. So inside the CF48's cluster, there's like a tiny Postgres that lives. And this these components basically enable your apps and services to run and operate on top of them. So this is what a cluster looks like. And external to this cluster, there's like container registries and app registries that you can also work with if needed. And obviously, external to this cluster on the developer side is CAP and YTT and all of these different tools that you might need. Now, this is a view of CF Arcade's networking, but I'm going to skip it in the interest of time and because I don't want to make this sound more complicated on a on a Saturday morning. But very quickly, let me. Do I still have time, Harshita, to go over a few things?
Yes, sure, sir.
Okay, so just 5 minutes, all right. Um, so I have a deployment on Google Cloud. It's running on GKE. So if I just open my Kubernetes engine, so this will show you my cluster that I have, and sorry, I'm logged in as the wrong person. Just give me one moment to do this. But basically, I wanted to show what my Kubernetes cluster looks like. And please forgive me for not being as prepared. So hopefully this works. So I just wanted to show how my cluster is organized, what it has, and how how functional it is. There you go. So this is my cluster. I use it for a lot of demos. Basically, it has 5 nodes, each with 4 V CPU and 16 gigs of RAM. Now you can see all of the different workloads that are operational on this. So every little block that you just saw before basically has corresponding pods here that you can see. So that's how we accomplish deployment. And there's also like a mini broker for services that is there. You can replace this with like any open source service broker um, stuff. So this is running, and so in order to just push an application here, all I have to do is on my command line, I can connect to this um, service and just deploy to that. Now let's see if I can do that very quickly within the time that I have. I'm guessing this is my give my typing skills. Let me make this bigger. So I'm just trying to like set my API endpoint and log in to my Cloud Foundry instance. Um, So Cloud Foundry basically has like a um, command line interface, oof, which you can use to connect. Oh, maybe I have to log in. Sorry, but okay, I can skip that. It's a few steps, but um, what I'd like to emphasize to people, and let me like show a few things before that. So um, we are at all of this is at github.com/cloudfoundry. So just look for the CF for Kates project. That's our open source. I definitely encourage you to give us a star while you're here. Um, but I don't think we are on Hacktoberfest, so please spare us some of the PRs. Um, but this basically is a great starting point for trying Cloud Foundry out. Now there are some publicly available Cloud Foundry providers, but they do not deploy to Kubernetes as far as I know. So they're all just like cloud providers. So definitely attempt to deploy this on your own infrastructure. We have very specific instructions on our Medium blog. So you will recognize my face and one of my colleagues. Both of us, try to break down a lot of information that you need to deploy Cloud Foundry to any infrastructure of your own. So there's stuff for Google Cloud and DigitalOcean on there. Azure will be up next week. I know it works for a fact. Um, Kind clusters are also rather kind to us. So if you want like local deployments, do try on Kind. I haven't yet tried on Minikube myself, but I've heard people in the community have been successful. So that's another place to try. And AWS has a few wrinkles that we're still ironing out, but we should be able to do that soon, I guess. Um, and obviously, for whatever pull requests or feature requests that you might have, definitely try and contribute to those either by yourself or give us enough information so that we can pick up the stuff that you really need and stuff that makes sense, and um, uh, try and include that to future releases and versions. um, Cloud Foundry folks are available at Cloud Foundry on Twitter. So if you have any questions or if you need any kind of support, definitely reach out. The best place to reach out though is our Slack community. So please, 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 if you've not already joined in the past, I would definitely encourage you to join in future. We have a wonderful community of people who are very happy to help other folks, and they definitely respond on time, and they're very patient and welcoming. So definitely join the community. The channel that discusses CF for Kids specifically is hashtag CF for Kids, obviously. So you'll find a lot of people who are getting started, who are experienced on all of these things there. So you can get a lot of clarification. I showed you the GitHub page already, so you can go ahead and get started with that. So thank you once again to all the organizers. I'm sorry that I couldn't like do a full demo of what the experience is like, um, but for those who are interested, there's a lot of information on the Medium blog and in a few other places. And if you care to follow me on Twitter, I can share that information with you as well. So yeah, thanks once again for your patience in listening and joining on a Saturday morning.